Okay, Sam.
I got it. Okay, so just want to go over just with a few students on the assignment that was uploaded. I was hoping for Tech 1 to turn to have the assignment up to number 1 to 10 to be uploaded, but look like a lot of people missed that. So, okay, let me go ahead and share the screen real quick. Okay, so this is everyone that is in Tech 1. As you can see, we got up most people are able to. So like I said, my goal was to make sure that everyone have assignment up to number 1 to 10 turn in right now. This one is due, and then the next set of 10 will due by the end of April, or by the end of this month. Another set of 10 must be turned in because we need May is coming up pretty quickly. And so if I miss any one of your name and you think you turn in your assignment, and these are the only one that I was able to account for. Okay, so if I think you think that I missed something, let me know, and so I can make the correction. Okay. So look like Hernando, you did all of them so far, so you're pretty good. So you're ahead of the class. Nicholas, you're already pretty good. So you only have one missing assignment, number 14. So I think you're on good track. Okay, so. And look like Jose Pareda, you're doing pretty well. You're only now 12, 13, and 14. So those are, you're on track. Okay. So we got only a couple of students that's still on the assignment number 8 is still failing. Like I said, the assignment 8, there is 2 parts to assignment 8 on that. So assignment 8, you go, let me see, assignment number 8 would be here. So the diode here. Okay, so when you work on that assignment, okay, let me see, okay, so enable. Okay, so your assignment on the first page right here, you do all the multiple choices answer. Okay, and then you have if you look at the bottom left corner here, you got the page for the quizzes, and then you got page for the problems. And most of you did the quizzes, but you did not do the problem. That's why it still say fail or incomplete. Okay, so you need to go back and redo that assignment 8 and make sure you do the quizzes or you do the problems. And that is for the assignment number 8. People turning in, they missed that. Quite 2 people missed that. So there's like I said, assignment 8, there's 2 parts. Okay. And then for Ryan, look like assignment 10 you turn in. That was fail on assignment 10. So go ahead and try that again and see if you can redo it and get it to pass and re-upload it to the website. Okay. And for Tech 2 student, this is what I have so far for everyone. Now Dario, look like you're okay. Look like you have on DLab 3, you fell in test 3, okay, on your software. So fail test on DLab 3, you failed test 3.
Okay, thank you.
You're welcome. And then we got for Jennifer and Emily, you're like, okay, for Jennifer, you got DLab 3 and DLab 6, you got a compile error on your software. I was running and then there's a compile error, so fix those and re-upload it. And for Emily, look like your DLab 5, there's also there's compile error on your software. Okay, so go ahead and fix that and re-upload it to the website. So this is what I have currently, and if you think I missed something, please let me know so I can go back and recheck on the website. Okay. All right, so is everybody okay with this, or anybody have question?
I have a question on mine, but I guess it failed since it's not on the list, number 2. So I guess I'll figure out tomorrow.
I haven't seen anything on your for DLab 2.
Yeah, I probably uploaded because I went through the other way you uploaded through the instructor.
No, this is the software that you had to upload onto the website.
Oh, okay. Yeah, I think I did it wrong. I'll fix it tomorrow, or I'll upload it tonight.
Because I look at here, I don't see any, let me see. Okay, for Viola right here, I don't see any DLab. So here's DLab 1, DLab 1, DLab 1, 2022. I don't see any DLab 2. Okay.
Yeah, I probably put the wrong name. Yeah, I'll fix it tomorrow, tonight.
Okay.
Thank you.
You're welcome. Okay, so we got that one clear. So, okay, so anybody still have question about their assignment that they have to work on?
I do have a question about assignment 12, so this is tech 1.
Okay, go ahead, Jose.
The question is, I can't get any signal. There's a signal generator that is part of the second portion of assignment 12.
Okay, are you on assignment 12? Okay, do you have it on your computer right now or?
I do. Yeah, I can show
Okay,
you.
yeah, go ahead and share the screen. That would I can help you quickly. Okay, so that's around MSIM 7. Okay. Okay, so you're doing the second part. Okay.
And
all right.
yeah, so the question is, I don't see any signal coming out of this, or and I don't know if I have either the signal generator not set up correctly, or what the problem may be.
Okay, go ahead and click on your generator to, I want to see your signal in the
Let me bring
generator.
it down from my other screen. 1 second.
Okay.
Oops.
Okay, go ahead and turn it on. Okay, so we need for this one, we need a 1K at 300 millivolt. Okay, go ahead and go to the amplitude button. Okay, 300. Okay, that looks good. That's AC input. Okay, that looks good. Okay, go ahead and run your simulation. Okay, can you show that?
Yeah.
Can you show on the oscilloscope one?
Mhm.
Okay, so are we looking input? Are we looking output?
We're looking at input, and this is where I connected it. Actually, I think it should be right after the capacitor, right?
Yeah, you could be, yeah, it should be at the input. That would be before, yeah, before the capacitor. That's fine. Go ahead and show me the oscilloscope one more time, please.
Huh?
Okay, okay, go ahead and turn on your simulation. Okay, so yeah, go ahead. Okay, there is, you do have some signal, but it's out of range, so you have to adjust your volt per division right here, but under the number 1. Okay,
Right.
so, no, the bigger button. Yeah, you have to scroll it until you get a, yeah, we'll bring it down a bit. Okay, now just use that and then go to the top, yeah, that one, scroll it to give it a little bit more. Okay. Okay, now go ahead and stop your simulation and rerun your simulation. Okay, go ahead and rerun it. Okay, so we need to, yeah, you have to give it a little bit more signal. Right now you are so zoom in so close. So come back into your generator here and go to the top turn controller, give it some more. Okay, the other way, more. No, the other way, to the right, turn to right. Okay, go ahead and do just do one more. Just a little bit more, just a little bit more. Okay, right there. Go ahead and go up to the top and turn off your simulation and return on the simulation. Okay, so now we started. Okay, so we're looking at, look like in the microvolt. So we look at, yeah, so we're looking, okay, so we compare where the number 1 is at, go to the top of that scroll. Yeah, go ahead and turn it. Let's go ahead and go to about, no, you were going to 100. We need to go into about maybe close to about 500. Or maybe, yeah, we need to keep on going the other way. I think it's still in micro. Okay, so 300 millivolt, that would be 300,000 micro. So we need to get something close to the 300 range, getting close to 300 range. Okay, so we're getting close to there. Now we're at the one. Yeah, you got at the, go to the millivolt. You see at the top left corner right there, top left corner. It say right now it look like 500 or. Yeah, it's so small. I can't see it on that well. Okay, no, yeah. Okay, hold on, hold right there. Okay, come back under the button on top of the one.
Mhm.
Okay, turn it until we get into the millivolt.
Okay.
Okay, just give a little bit more. Okay, right there. Go ahead and turn off your simulation and run. Yeah, you have to keep on playing with those buttons. Because right now we're zooming way too close. And so, okay, go ahead and just click on auto scale. And then go to the bottom here where the where it's saying green, said undo auto scale. Or yeah, just keep on just keep on playing with that. Just keep on adjusting because like I said, you're zooming way too close and you can't see the signal.
I think I know. I see how to play now. Okay.
Okay.
I can take it from here. Thank
Okay,
you.
good. Okay.
Thank you.
You're welcome. Okay, any other question? Tech 1 or Tech 2? Okay, so everybody's good. Okay, back to you, Mr. Pham. Thank you.
Thank you, sir.
You're welcome.
Okay, let me go back to my iPad. Okay, last time we already get to differential amplifier. And also we get to the decibel. Okay, so today we start with the operational amplifier, op-amp. And you can see this is the op-amp here. 8 pins, okay? First thing they say 3 terminal, okay? They can get input positive, input at the negative, and the output. And you understand the inside here, just the transistor, okay? That's what we already see in the differential amplifier, okay? And now you can see one input goes to the negative to get the name inverting input, and the one goes to the positive input, they will be a non-inverting input. Okay, so they already said inverting input to the minus side, non-inverting input go to the plus side. That's the basic definition, okay? And you have to memorize it. When they're talking about inverting input, then you know where they connect you on an inverting. And also you get an output, they need a dual power supply, not so up here. Normally the power supply for the op-amp going from plus or minus 8 volt to plus or minus 38 volt. If you're using positive 15 volt, then the negative will be minus 15. Okay? And now we're looking into the op amp. You get that one inverting input, non-inverting input. However, we're talking about VD. We already learned from differential amplifier. What is the VD? VD, that means the different voltage between V at positive minus V at negative. That's the definition. Okay? And when you're looking into the op amp, you can see they get the input impedance, and they want that to be infinity. That's only telling you one thing. The current is not go to the op amp. Why? I think that they get a very high input impedance. And the op amp also, when they go into the output, they get the output impedance. And they want that output impedance to be 0. The thing that they want more current will be coming out. So that's why output impedance, they want it to be 0. Okay? And also, op amp, they get the gain. AV, that means the voltage gain. And they wish that to be infinity. That means very big. Okay? So now, when you're looking into the op amp, at least you have to recognize or not the thing we just bring it up to you. When we're talking about ideal op amp, basically you cannot get ideal anyway. However, they're telling you open loop gain, AOL, will be infinity. The thing is you want the gain will be very big. For the ideal, you want that to be infinity. And also the input impedance, you want to be infinity O. And the output impedance, they want it to be 0 O. Differential input VD equal V at positive minus V at negative of the op amp have to be equal 0. That's telling you what? That's only telling you V in at positive and the negative, they will be equal. Okay? Any question regarding to the first introduction into the op amp? Okay, now go to the next one. This is the IC. When you're working on either take you the left, later on you have to deal with that, or you're working on the left volt. You can see that 741 op amp. And basically they're telling you 8 pin, what pin will be what? Pin number 4, negative power supply. Okay, pin 7, positive. Okay. Pin 2, that are inverted input, and pin 3, none, inverted. And pin number 6, that is the output. Okay. practical op-amp. Okay. Now, this is a practical op-amp. They get a high voltage gain, very high input impedance, very low output impedance, and wide bandwidth. Okay, that is basically for practical op-amp. That means they're not talking about gain equal infinity. They just want to get a high voltage gain. Also input impedance for the ideal the infinity ohm. However, practical, they will be a big resistance. Okay. And the bandwidth, they want wider. Practical op-amp, okay. Output voltage V out, okay, equal V in at positive minus V in at negative time to the gain. You understand the gain EA, voltage gain. OL means open loop gain. Okay? That will be equal VD. VD we already telling you. Difference between V in positive and V in negative. Time AOL, open loop gain. VD, difference between two inputs. The gain AOL open loop gain of 741 op-amp close to 200,000. The output of op-amp is never higher than the power supply voltage. What that means? If you're using the power supply voltage plus or minus 10 volt, then they can guarantee output of the op-amp, no matter what input or gain, cannot be higher than 10 volt or minus 10 volt. The thing is, when you try to get a higher gain or higher input voltage, the op-amp will be saturation, no more amplifier. Then the output either go to positive saturation or go to the negative saturation voltage. And saturation voltage normally less than the power supply, around 1 or 1.4 volt. Okay. When input apply is too high, that force the op-amp into the saturation. When the op-amp is saturated, you cannot using any more gain. And the op-amp output will be equal to plus or minus saturation voltage, less than power supply, about 1.4 volt. Open loop gain, AOL, is defined as the amplified output amplification without any external feedback signal connect to it. And for a typical operational amplifier is about 100 decibel at the DC 0 Hz. This is we try to summarize everything regarding into the op-amp for you, in order you can understand it. That's a minimum thing. You better keep it over and over to get along and try understand. Okay, now you can say this example. an op-amp had open loop gain AOL 200,000 with a power supply plus 15 volt and minus 15 volt. They given a saturation voltage of the op-amp, the same with the power supply. Okay. They want you to complete the VD and the VOut in the following table. Number 1, they given you input positive 20 milli-microvolt, input negative 40 microvolt. They want to get the VD and they want to get the VOut. Can you do that for me? What VD equal?
Number 1, negative 20 microvolts.
Is it minus 20 microvolt, right?
Yeah, minus. B out, negative 4 volts.
Okay, VOut negative 4 volt. Did everyone agree with that? What I said to I have to working on, okay, in order to make sure you understand or not. If you get it wrong with the answer or different with the answer they show up right now, just bring it up. So that's why we can help you to make it clear. Okay, I need to show you a few things before you're able to do. Okay, now try to understand. Okay, so basically you get AOL. Okay, and let's see, you get blood saturation. Okay, so the op-amp can be using an amplifier, or they can be saturated. So if they saturated, they don't care about the gain. The output will be equal to plus V saturation or minus V saturation. So now we have to calculate to see at blood V saturation, what the input VD is supposed to be. So we can say at blood V saturate, okay, and the V in equal 50 divided again equal what? $15 divided 200,000. Look like 75 microvolt, is it right?
Yes, that's right.
Okay. And now if they add the negative saturation, then V in, that means the VD. Okay. We have to say VD. Minus 15. 200,000. And now you see they equal minus 75 microvolt. And now you can see that is a VD. Right here is 0 volt. Okay. And they can be equal right here. 75 microvolt. And on the other side, minus 75 microvolt. So basically, any VD higher than 15 microvolt, so the op-amp will be saturated. And any voltage less than minus 75 microvolt, they also be saturated. Okay. So basically, they only be amplified here. At this point, that means the input less than 75 microvolt or higher than minus 75 microvolt. Then you can calculate V out equal VD time well. What happened V out at this point here? What V out equal?
Positive 15 volt.
Positive saturation, right? And any voltage D, VD less than 75 microvolt, V out equal minus saturation. So if you understand on this thing, you're able to complete that example. Any question on that explanation? Is it helping you or not?
Yep, this helps me at least.
Okay. Complete that for me. As soon as possible. What I said is try to do by yourself, okay? So you can compare to the right answer. Who get the second one?
It's 70 microvolts.
Exactly, 70. What we out?
14, 1, 4, positive.
Right?
Yes, sir.
Okay. Is it that number 3? Is it minus 20?
Yes, minus 20.
And that will be minus 4.
Yes.
Okay. Next one to me is a 140.
$140 or $145, Mr. Fan?
You take 20 minus to minus 120.
Mhm.
So have to be 140.
Oh, yeah. Okay. $45.
I don't know, I right or wrong. Check it out.
I think all correct.
Looks good.
Yes.
Okay, so any question about this example? If it's not, move it up. Okay, now input signal. They apply the input into the negative inverting. Input positive rounded. Input applied to either positive or negative of the op amp and the other input connected to the round. Okay, either one. You can see that on the second one, they apply to the positive, negative round. And the last one, they apply both input to negative and the positive. Okay. However, if you're looking into the diagram, one thing you must be recognize. This is the input go to the inverting input, and that will be go to positive. And they must be opposite polarity. This going up, this have to be going down. This going down, this have to be going up. If they both the same, they consider to be common mode. Okay. What they said, two signal voltage of the same phase, frequency, and amplitude are applied to the inputs. When equal input signal are applied to both input, they cancel out, resulting in a zero output voltage. If you apply both input signal identical to positive and negative input op amp, output will be zero. That's what they call common mode. Op amp try to reduce the noise. When the signal identical in both input, they consider to be the noise. And the op amp try to cancel that. Input offset voltage. Okay. Now I can show you here. Okay, when you get a two input, inverting, non-inverting, connect to the round, 0 volt. Output supposed to be 0. However, they get an offset. They can be measured V out equal 10 millivolt. That's what they're talking about, offset. So that will be telling you, if you apply 5 volt at the input, output measure supposed to be 5, but they cannot. The thing is, they get the 10 millivolt offset voltage. So the output supposed to be 5.1 volt. They including the offset. Okay. So in order to correct the offset, normally if you're looking into this circuitry here for that op-amp here, okay, they can tell you input offset, okay, and also the input offset. So they will be connected to the port, the resistor. When you connect input pin 2, pin 3 to the ground, you adjust that resistor until output to be 0. Okay? Whoever working on the left volt, then you will get the time to exercise that. Okay, see, this is what they telling you how to adjust the offset voltage. Pin number 1, pin number 5, they connect to the port here. Okay, and they connect in the middle of the port into the negative here. Okay, and they connect the output to the meter. Okay, and basically you have to connect input both to the ground. They're supposed to be 0. If they're not 0, you adjust this port right here until they get 0. Okay, adjust the offset voltage. Connect port to pin 1 and 5. Connect both input of the op-amp to the ground. Adjust the port until V out very close to 0. That is the way to adjust the offset of the op-amp. Now, go to next one. They're talking about open loop and the closed loop. This is the open loop. That means when you buy the op-amp without any connection, then you get open loop. And we already know the gain of the open loop will be V out divided V in. Now you tell me what V in equal. What V in equal?
V positive minus V negative.
Exactly. V in this case will be equal VD, right? That means the difference between V at positive minus V at negative. And the gain for the open loop gain, they will be around 100 dB. Or they will be same thing, 200,000. That's for open loop gain. Now, that we're talking about closed loop. Okay. when they connect the RF, that means the resistor connect from output back into the input. RF will be a feedback resistor. Feedback means they connect from the output back into the input. Okay, now what the voltage at this point?
Zero.
Zero. The thing is V at positive and V at negative equal. V positive connect to ground, 0 volt. Then this point also 0. However, they get a different name. Who already get through electronic? What the name for that point?
Version cao.
They get a different name, virtual route.
Yeah, I'm close.
Yeah. Okay, now, what's the difference between this route and virtual? What is this route?
Physical ground.
Physical route.
Yes, physical ground.
What is a physical route?
0 volt.
I understand both is 0 volt. However, you said this is what we call a physical route.
A physical connection to the ground.
Exactly. Physical route, that means you need a wire connect to the route. And the difference between virtual route and physical route, even both a 0 volt. However, virtual route still allow the current can flow it. I can give you an example. If you get a current flow here, when they go up to this point, where this current I will be go into here, go down here, or go up. First thing, is it they go into the op-amp?
No,
No.
I don't think
there's no voltage.
it's high impedance.
Exactly. The thing is inside, we already said they get a very big input impedance. So that's why current cannot go into the op-amp. Second thing, what happened if they going down? Can they going down? And it going down. Oh, tell me. Yes or no? If no, how?
I would say no, because we still can't get anything inside into the closed loop.
No, that's not quite. I agree with you. No, they cannot going down. But I want to know why.
There's no physical connection.
No, that's not. The thing is, you see no physical connection. However, that's not the reason. Okay, I telling you. What voltage here?
Zero.
What a voltage here?
Zero.
So that's why they cannot flow it, right? They get the same potential. Five volt. Current have to be, right? Current have to be flowing from a higher potential to a lower. If they get the same potential, no current can be flowing. So that's why what we said, you get a 0 here, same potential, current not flow here. That the current will be flowing this way. Positive here and negative here. Okay. So summarize for this part here. First thing you have to understand what they mean for feedback resistor. Feedback resistor means the resistor connect from the output to the input. Okay. That's what they call RF. However, at work, you cannot see any RF. They get resistor, but they're using the number. R1, 2, 3, 4, 5, 6, just a number. Not in the textbook, they're using RF for feedback. Second thing, when you get this point at 0 volt, then they get the name is virtual ground. Okay. And if you say they calculate here ACL, that means closed loop gain. So when the op-amp connecting to the circuitry, they get the gain they call a closed loop gain. Op-amp itself not connect anywhere. That's what they get the gain they call AOL. And ACL will be depending on the circuitry. They can be equal whatever. For example, in this one, they given you equal minus RF divided to R1. But make sure you understand, closed loop gain basically depend on the circuitry. Okay, any question? Now, try to understand on this thing. You can explain to me what is a cutoff frequency? What is it? Cutoff frequency. They get a different name. Cutoff frequency or critical frequency or break frequency. That means they get a different name, but the same thing. So now you have to tell me what the cutoff frequency. What is it?
This way is minus 3 dB.
That will be telling you at this frequency, output will be going down minus 3 dB. That's a definition. That means at the cutoff frequency, output going down minus 3 dB, equivalent to 0.707 volt. 0.707, equivalent to 70.7%. Okay. Now, when you're looking on that output curve, normally they're using a response. That means the output curve here. Okay. Cutoff frequency right here. Okay. They're telling you they're going down to 100 dB. Can you tell me what is the frequency at the cutoff frequency? You see, they're showing you this for the gain A, this for the frequency in hertz. So at the cutoff frequency, what that cutoff frequency equal?
10 hertz.
How many?
10 hertz.
10 hertz, correctly. You going from here, going down. That means at the cutoff frequency, there will be 10 hertz. Normally for anything, design anything, after the cutoff, they don't care what's going on here. Okay? That means the circuitry only working from 0 up to 10 hertz. That's impossible. Okay? So if you want the bandwidth. Okay, now from here to the cutoff here, that's what they're talking about, bandwidth. If you want to get more bandwidth, that means more frequency, what can we do? I give you an example. If I pick the point right here, critical frequency here, what the gain? You go to the left. That's what you get right here, 60 dB. So that will be telling you the gain will be reduced from 100 dB to 60 dB. What is the cutoff frequency?
10,000.
10,000 hertz. So if you want to open the bandwidth now will be this way. Then you have to reduce the gain. And you can see the point at this point right here. You can see the gain going down only 20 dB. However, bandwidth will be go up to 10 to the power 5 hertz. Okay. And finally, at this point right here, 10 power of 6, that means 1 megahertz. And the gain will be 0 dB. 0 dB mean, right? The thing is, you take a 20 log of 0, you get a 1. 1, that means they say unity gain. Unity means 1. Gain equal to 1. And the bandwidth will be equal 1 megahertz. That tells you how this graph working. A lot of students, when they see on this one, they not quite follow it, not quite understand. Basically, they just telling you, you want bandwidth wider, then you must reduce the gain. Okay, now, inverting amplifier. The reason we call it inverting, the thing is the input applied to negative, inverting input, okay? Positive routed, okay? So now, again, if you get a current I, then you get positive here. You get negative here. Okay? Current I from the input, when they get into the virtual ground, then they go up here. This is a positive and this is negative. Now, if you get a negative right here, then the output also have to be negative. The reason is this is just a wire, okay? So polarity both be the same. And if you get a negative on this side, VL on this side must be positive. Okay. Okay, so this side must be positive. So this current coming in up down here.
Share your screen.
Stefan, you need to share your screen.
Oh man. Okay. Thank you. Okay, so that current I go this way, I going down here. Where did I go? Is it going down? Is it go up here? No.
Go inside the amp.
Why? The linear current have to be flowing from higher potential to lower. Current have to go this way. Okay, so this current I, they not going down. They go inside here. That's what they call a sink current. What that means, sink current? That means the op amp pull the current into the op amp. That's what they call a sink. Okay. And also at the output here, you can get the current go this way, coming in also. That's what they call IL, I load. So if you want to calculate the total current of the op amp, I out will be equal I load IL. That's the op amp current. If you're looking into circuitry, how can I calculate the current I?
Measure the voltage across Rin.
Okay, if you're looking here, you can see I equal V out divide F, right? The thing I did one will be ground. Okay. V out. That means the voltage from the output to the ground. So they can be from here to here, round. Or they can be from here to here, also round. Okay? So you can calculate the I equal V out divide RF. Or you can calculate the IL V out divide to RL if you get RL. And now if you're looking into the input here, you also calculate I. What I also equal? Remember, this will be round.
V in divided by R in.
Exactly. V in divide R in. Okay, so let's see what they said here. RF feedback register between output and inverting input to produce closed loop gain, what they call ACL. No current flow into the input terminal, high input impedance. The different input is 0. So VD equals V1 minus V2. That will be only telling you the voltage V1 here, V2 here equal the same. And the closed loop gain, this will be equal minus RF divided to RE. I believe this one they will be proven. Now, on that one, current I, V in divide R1. V in is 5 volt. Divide 1K. You get 5 milliamp. That 5 milliamp. Closed loop gain ACL equal minus RF mean R2. Okay. Divide to R1. So 1.5 divide 1K. So they will be equal minus 1.5. That is the closed loop gain. If you want to calculate the V out, ACL times V in, you take the gain minus 1.5 times 5 volt. You get minus 7.5 volt. That's why they call it inverting amplifier. Inverting means input positive, output negative. Input negative, output positive. Okay? And also they show you, if you want to calculate the load current IL, this is the current IL, will be equal 7.5 divide 5K, you get 1.5 milliamp. Okay? And the op-amp current will be I plus IL. You can get 6.5 milliamp. Okay, you go through this example. Just apply the formula. Try to see you get any question. Okay, so you do it for me now. This basically from the left volt inverting amplifier. Quickly get through it. This is just a very, very basic, okay? Minimum thing for technician must know. We're not going to the too complicated circuitry. Very, very basic. If you cannot get through it, what can I do? One, two, three, four, five. Get through it quickly. thing I did quick, we try to cover most of the operational amplifier and also including anything related into the op-amp. Hopefully next week will be done. Then the following week we'll be talking about JFET or filter. Then we'll be done for the lecture. Okay, then ACL equal what?
-10.
Is it correct?
Yes.
Okay. Be out.
-10 volt.
Exactly. Current I through R2.
So it's either 1 volt divided by 1K, so it's equal to 1 pi.
Is that 1 milliamp?
Correct. Load current.
1 milliamp.
Op-amp current.
1 plus 1 equal to 2.
Perfect. That's what I want. Just only looking into that, you can know right away how to calculate it. Okay, try this one. Only the difference will be AC signal, not DC. Number one, ACL.
Three.
Negative.
Minus,
-3, yeah.
is it 3, right?
Yes.
Be out.
3.6.
3.6. Why you don't have a negative?
Because it's the voltage, the phase, the negative just tells you our phase.
Be out, you don't have a minus 3.6. No minus. The thing is why no minus?
It go from positive to negative to positive.
The thing is that AC signal. Okay? AC signal, that means they vary between positive and negative. So that's why they don't have a, you cannot put minus 3.6. The gain equal minus only telling you input, output will be our phase. So that's why you can see input positive, output negative. Input negative, output positive. Okay? However, when you're doing calculation V out, cannot put any positive or negative here. Okay? The thing is that just as AC signal. Current I through R1.
Specific.
0.8.
0. What? 1.5 1.2 divide 1.5. Okay.
0.8 milliamp peak to peak.
Okay. Zero point 0.8, right?
Yes, sir.
Okay. So, but I said in here, the input output is inverted or 180 degree out of phase. So this is an example for inverting amplifier with the signal will be AC, not the DC. Any question? If it's not, try see. Non-inverting. Now you can see input here apply to positive. So that's why they get a non-inverting amplifier. Okay. So first thing, input of the op-amp must be at this point. Okay, not here. Must be here. If I say this is VA, can you tell me what VA equals? And also here they call VE. You can see this is a voltage divider. 1K, 1K, and this is a 5 volt. So VA will be equal V1 times R3 divide R2 plus R3, giving you 2.5 volt. So if you want to calculate the input of the non-inverting, they must be connected directly to the positive. Okay? So now you get a V in or VA, 2.5 volt. My question is, what voltage at this point?
Same VA.
Exactly. They will be 2.5. And not virtual route, okay? Only thing if they connect to route, then they could be a virtual route. Now they're not. However, we understand the difference between plus positive and negative is 0. No difference. So if you get a VA 2.5, then you get at this point 2.5. And also we'll be telling you this point 2.5. Same thing. So now you can see you get a 2.5 volt at this point. This is a round, so that's why you get current I. What I equal? you get only one source, one resistor on law. 2.5 divide 1K. That's what you get, 2.5 milliamp. And this current I here coming from where? They coming from here or they coming from here? First thing, current cannot coming from here. Why? They get the same voltage, 2.5, same potential. So that's why they cannot get this current. Okay? So that current have to be coming from here, I. And this will be positive, and this will be negative. Okay? And this current coming from, now, if you get a positive, then you get a positive on this side, negative on this side. So basically, that current will be coming from the op-amp. So in this case, they call a source current. Okay, source current, that means op-amp generate the current coming out. Sink current, op-amp pull the current into the op-amp. Also, you can get the IL, will be go this way. Okay, so we already given you any calculation here. ACL, the gain, 1 plus RF divided to R1. Okay, and if you want to calculate the V out, will be equal to ACL times V in. This is the V in right here. I out equal I plus IL. ACL always greater than 1. Why? The thing is they equal 1 plus something. So that means for this non-inverting, the gain all the time must be greater than 1. Okay? If you want to calculate the V out, you take IL times RL. And V out also equal VRF plus VR1. Now, V out means V out right here. V out will be measured from output here to the ground. And also that means from output here to the ground here. In order to get the voltage, you can take the voltage through RF, add the voltage through R1, also equal V out. Okay, that's what I explained to you here. V out equal RF times R1. Okay, and I times RF plus I times R1. Okay, that's what they given to you. Prove it why they equal 1 plus RF divided to R1. So we already get through. One will be inverting amplifier. Another one will be non-inverting. So try to look through it again. Okay. So for the next meeting, will we try to get better understanding? Okay, you get any question, anything up to this point? This is a very important, okay? So make sure, try to understand. Any question?
Yeah, Mr. Pham, make sure you upload this on the web and make sure you fix that cell on number 8.
Okay, I will working on the lab number 8, looking into that, what's going on, okay?
Thank you.
You're welcome. Okay, any question? Okay, again, any textual, you get any problem, anything with the lab, please text to me. I could be on Zoom with you. To helping you to get through it. You don't want to stay up until I retire. Okay?
I want to stay till you retire, Mr. Pham.
The thing is, you don't need the job. However, students here, they still young. They want the job and also they want to be engineer some days. Okay? So if it's not, then you'll be good night, everyone.
Good night,
Thank
Mr.
Thank you,
Pham.
Mr. Pham, for class.
Good night.
Good night.
Hi, thank you.
You're welcome.
See you.
See you.